We are live.
Namaskara, everybody. So today, before starting with the session, I'd like to give an introduction on our BSKB association. That is, it is popularly known as Gokul, which is a 96-year-old charitable trust in Mumbai. And our activities include a community center at Sion and a home for senior citizens at Nerul in Navi Mumbai. With over 5,000 members, we have been actively interacting for religious, cultural, and social causes. BSKB Youthwing is conducting Sunday interactive sessions along with the Talent Hunt series. Today, we present you a talk by Atul Bhat on calendar from Astronomy. So before starting with the session, I'd like to give a small introduction about him. Atul Bhat, he's an assistant professor Purna Prajna in Purna Prajna College, Udupi. He's a coordinator of Purna Prajna Amateur Astronomers Club. Also, he's also involved in popularizing astronomy through the club. So I hope today's session will be very interesting, and many of them will like to know the insights about the astronomy. So over to you, Mr. Atul Bhat.
Opportunity. Yes. So when I was asked to give this talk, I usually like to talk about astronomy and the beauty of astronomy. But then what fascinates me is that all of us learn astronomy from school. Although we don't have a particular syllabus in astronomy, we don't have a particular a chapter that teaches us astronomy. In school, they unknowingly teach us astronomy. And that is what I want to talk about today. We are all taught in school that there's about 365 days in a year, and there's 7 days in a week, and there's 30 days in a month. We are also taught about the 12 months in any given year. Sometimes they talk about a leap year. Every 4 years, you have one extra day in February, and so many other things. Why does February have 28 days? That's not astronomy. That's something political there. But then when it comes to why 30 days in a month, why so many days in a year, these are all astronomical facts. But then none of this is taught to us as in terms of observations, because we all can do these observations as well. So on this topic, I would like to keep this topic very simple and at the same time very engaging, so that whatever I speak here today, you guys can go out and explore. Everybody can go out and check. Everybody can go out and note and verify. So let's not take all the months for granted. Let's not take all the weeks, 7 days a week for granted, or leap years for granted, because we need to know the astronomy behind this. So today I'm going to do a small presentation on this topic. Of course, as usual talks go, there will be a small PowerPoint presentation which will guide me with the images and labels. But then what I'm going to do is going to show you astronomy, the night sky, virtually, because right now I can't ask you to go out and check out the sky because there may be clouds, the sunlight is not going to show you any stars, and so on and so forth. But there's a software called Stellarium. Anyone can download this. You also have a phone app for this. So using the software, I'm going to show you the sky virtually. So let me share the screen, and then let me just, yeah. So I hope the sky is visible right now. What you see is the complete view of the sky, the panoramic view of the sky. So right now,
yes,
you can
it
see
is
the
clear.
sun. Yes,
Yeah,
great.
we can see.
Okay. So right now you can see the sky is usually set to my location wherever I am. Wherever, when you install it, you can set it to your location. Right now it's set to Mangalore, but then it doesn't really matter. In India, it's it's going to be pretty much the same sky. So now you can see that the sun is towards the west. Of course, it's quite intuitive right now that the top is north, the bottom is south, east, and west. So the entire sky is visible, and you can see that the sun is almost towards the west. But you can also notice that sun is exactly not in the southwest, but it's not in the west. It's slowly towards the southwest. I'm not sure if this label is visible here, but you can see this part of the sky, this part of that horizon here is labeled west, and the sun is not in the west. It's towards the south from the west. And we are taught in school that the sun rises from the east and sets in the west, but no, that's not exactly true. Of course, it rises and sets in that general direction, but then using the position of the sun also, we can make out the months, we can make out the seasons. That is also possible with astronomy. So right now, any day if you're well versed with the sky and the position of the sun and the stars, if you've got the sun towards the south from the west, and if I keep observing this for a few days, then I can kind of imply or infer that this is the month of January or February. So that is also possible. The sun will be exactly in the west in the month of March and September. So these are all things we can infer from astronomy, and we can observe this. But the more important thing is a calendar. In India, it's famous as the word Panchang, because Panchang is basically the word for calendar in India, and it also tells us about the entire whatever we have in the calendar system is exactly there in Panchang, but it's got different terminologies. What we follow, the wall calendar that we have in our homes, is the Gregorian calendar, which is given by the Western world. Pope Gregory was the one who designed or redesigned the calendar, and today the entire world accepts this. But even that came from astronomy. In India, we have different names for these terms from the calendar. Like for the month, we call it Masa. For the day, we call it Nakshatra itself. And there's a small bit of confusion here, because when I say Nakshatra, of course, that's the word for stars. And every day we name it as a Nakshatra. And then sometimes I can tell you which Nakshatra is which star, but then there are times when I can't identify a Nakshatra in the sky. So these terminologies are very important to us. So let's understand them one by one. So right now the sun is setting in the west, and this is of no use to me because you can see there's no stars visible. So with the help of the software, what I'm going to do is I'm going to disable the sky and the atmosphere. Now you can see all the stars. There's labels to some of these bright stars here, and there's also Jupiter right above the sun. Of course, you can't see it because of the sky now, but if there was no atmosphere on Earth, we could see Jupiter right above the sun. And very close to the sun, you've got Saturn. So all it takes for us to understand the sky is to observe the sky. And this is not going to happen just within a day or a few days. It's going to happen gradually over time. And that's how the calendar was formed. The calendar we have today is formed from the observations made for over centuries. And you see the entire sky panoramic view here. From north, south, and east and west, all the directions are visible. The entire sky is visible. This is how the sky looks right now. Of course, you can't disable the atmosphere when you go out. So what I'm going to do is I'm going to slowly disable, going to go forward in time. So let me just move a little forward in time here. So right now the time is 5, it's almost 5. So yes, let me just move forward. And about 8 o'clock tonight, of course, there'll be no atmosphere's disturbance. It'll be bright night sky. And this is what you'll see. You'll see various stars and patterns and so on and so forth. But what matters is you observe this every single day. So I'm going to slowly zoom out. Don't worry if you can't see the stars very clearly because it's a zoomed out view. But let's observe something. Let me set the time to 21:00. That's 9 o'clock tonight. And you'll see there's going to be no moon. Now, slowly, if I move forward, you can see every hour, the stars will slowly move towards the west. And tonight, the moon will appear only around the morning hours because we are very close to the new moon. I think it's on 1st Feb, you've got the new moon. So the moon is going to be appearing only a few hours before the sun. That's why you're not going to see the moon in a few days on February 1st, because the moon is going to be between the sun. And this has been taught to us. In school, they've told us that the new moon happens when the moon is in between the earth and the sun. The full moon happens when the moon is behind the earth when viewed from the sun, and so on and so forth. So I hope all of you understand the concept of new moon and full moon. But what happens is I am going to go forward in time with respect to dates. So let's say every single night you will go out and observe the moon at 8 p.m. So tonight, 30th January, 8 p.m. night sky will look like this. 31st January, slight variation. It's going to be pretty much the same. 1st January, 2nd January, 3rd January, 4th January, and slowly you'll realize around 4th February, you'll see the moon appearing in the west. There's one more thing that you need to observe about the moon. We know that the sun rises in the east and sets in the west. And I showed you a few minutes ago that all the stars in the night sky will move from the east to the west. So I can show this to you over here. Right now, I've got 8 o'clock set in the sky. And slowly, at around 9 o'clock, you can see the constellations have moved. The star patterns have moved. Slowly, again, it's going slowly towards the west with every passing hour. So all the stars will move from east to west. Let me come back to 8 o'clock. Yes. But if you observe the moon, Moon is that one object which is moving in both the directions. Why? Because on 5th February at 8 o'clock, if you notice, the moon will be closer to the western horizon. And as I go towards 9 o'clock, you can see the moon will slowly move towards the western horizon. This is possible. But coming back to 8 o'clock, if you observe the moon with every passing day at the same time, so I'm showing you the moon right now, the sky right now at 8 o'clock on 5th February. And if I observe it again on 6th February, you'll see the moon will have slightly moved towards the east. 7th, 8th February, 9th February, 10th February. So you can see every single day when I observe the moon at the same time, the moon will actually move from west to east. And this is what ancient humans identified first. And with this, they realized that if the moon is going to move every single day at a particular time, then with respect to the background stars, I can identify the position of the moon. And it will take about 27 days for the moon to come back in front of the same star. So you can see here, let me just set it to some date so that I can make it identifying. Yeah. So right now you can see the moon is above this 3 line stars over here. So this is about 11th February that I've set it to at 8 o'clock. Now, I'm slowly going to move forward one step at a time with every single day. So you'll see the moon disappear in a few days. At 8 o'clock, the moon is slightly going to move towards the east. So 12th February, 13, 14, 15, 16. So I'll keep on moving slowly forward and forward. And then you'll notice that the moon will once again appear above the same 3 stars on the 10th. So the moon takes about 27 days to appear near the same star again. And this is what they identified first. But there's also some other observations that you can do about the moon. So if I were to look at the moon every single night, so let me center it. Yes. So this is the moon, how it appears. So tonight, if you observe the moon, I told you we are close to the new moon, so we'll not see the moon for much of the night sky. But let's say Feb 4th, if you observe the moon somewhere in the night sky, early in the morning or evening, when you observe the moon, you'll see this is how the moon will appear. And slowly on the 5th February, if you observe the moon again, the moon will appear like this. 6th February, 7th February, 8th February, you can see on 8th February, the moon is half lit. 9th February, 10th February, 11th February, 12th, 13th, 14th. Slowly about 16th February, you'll see the moon is completely illuminated. And 17th, 18th, 19th onwards, you can see the moon is going to going to disappear slowly in the night sky. So about 18th February, just a second. Yeah, 18th February, 19th. Yeah. So can I move this? Yeah, 19th February, 20th, 21st, and so on. You'll see the moon will appear in phases. And the moon will slowly become brighter and brighter each day with a small dark region of the moon decreasing until the full moon day, which we call it today as Purnima. And from there until Amavasya, you'll see that the moon's visible region will decrease. And this cycle takes 30 days. So now, if I were to plot a calendar, if I were to make some readings from a calendar with respect to the moon's position with respect to the background star, then I would take about 27 days of a cycle. So it takes me 27 days to plot the moon with respect to the background star so that it comes back to the same position. So if I was supposed to make a calendar out of this, just the moon's position, then my calendar would have 27 days. And then if I were to observe the moon's phases, I wake up early or stay up late and observe the moon's phases. And then I will make down the different phases visible for the moon and make a calendar just from the moon's phases. Then it would take me about 30 days to get a complete cycle. So the moon's calendar, which we know as the Chandramana calendar in India today, we know that it has 27 days. But then if you go by the phases of the moon, it has about 30 days. And this is because of the geometry between the moon, the earth, and the sun. When I mention the sun, does the sun make such movements in the sky? Let's look at that. So again, on any given day, let me just go back to this evening. Yes. So this evening, if I were to observe the sun right now, you would see it towards the western horizon. And of course, I told you when the sun is out, I cannot see the background stars. So even if you go out at 12 in the noon, tomorrow at 12 in the noon, you'll not find any stars. So how will you identify the sun with respect to the background stars? This is possible, provided I know for a fact that the moon appears above our heads, almost at the zenith. Zenith is the point directly above our heads, and the moon will appear there at around 12 each night, which means every single day, if it appears at 12, every afternoon, it appears above our head at 12, then at around midnight, the sun is going to be directly below our foot under the ground. And the stars visible in the sky at zenith at that point, this point, at midnight is exactly opposite to the sun. This is an intuitive observations made. So let me call this blue point here as the zenith. So wherever I'm standing, whichever place I go, this will be my zenith. And the sun every single day as it rises at 6 in the morning, it will reach closest to this blue point around noon. And the sun will slowly move towards the west and set. And I can be sure that at midnight, these stars near this blue point here is exactly opposite to the sun. And using this, we can basically calculate the position of the sun. And when you make these observations with respect to the moon's position and the sun's position, you will realize that they always move along this orange line. We call this the ecliptic. Not very relevant, but we see that the sun and the moon are always above or below this point. So I can show this to you as I move forward with every hour. The line will also move in the sky, but the sun and the moon will always be very close to this line. The sun will exactly be on this line because that is the sun's path in the sky. And the moon will also appear very close to this point. So let me just go back in days and see the moon. Yes, so you see the movement of the moon is very close to this line. And using this path that the moon executes, what early astronomers did is identified various patterns in the night sky. So the night sky is filled with stars. You'll see so many stars over here. In fact, you'll see some stars over here. Let's see. Let me just go to tonight. Yeah. So tonight at 8 o'clock, if you go out and observe the night sky, in the south you'll have a bright star, and then right above your head you'll see these three lines. I mean, three stars forming the line. And if you look closely, you can see these three stars. If I imagine them to be the waistband or a belt, then you'll see another star, bright star over here. We call it Betelgeuse. And then there's another star over here. And these two stars will look like the shoulders. And then, of course, I told you this is the belt. So there are three more small stars over here that looks like a sword is hanging on the belt. And there are two more stars over here that form the foot or the knee. And the beauty of this is if you look towards their shoulders pointing forward, you'll see some group of stars over here forming a bow. And then in between the shoulders, you've got a small group of stars here appearing to be like a head. And this is Orion. So this is how you identify the stars in the night sky. Of course, when I say identifying the stars, I'm going to call them patterns and not constellations. I'll clarify that later. So when you look at these stars, it will appear like a pattern, as if a human is standing holding a prey or a bow, or depends on the culture that you learned it from. Similarly, if you have a hunter, behind this hunter, you will find a small group of stars over here. And you'll see that behind the hunter, just behind him, this star over here, this group of stars over here, will form a shape of an animal. So you've got a bright star over here. This is in fact the brightest star in the night sky. Sirius we call it, or Lubdhaka. And then if you consider this its shoulder of that animal, then you've got another star forming the front limb. and another star below it here forming the body or the torso of that animal, and then another star forming the foot or the hind limb of that animal, and then another star forming the tail of that animal. And of course, man being a hunter gatherer, those days identified this as a dog. And today we know that's as Canis Major, the dog. So this is how you identify the patterns in the night sky. And early astronomers or humans who were plotting the moon's position with respect to the night sky observed these patterns. So let me bring that line I mentioned about where the sun and the moon will move. And now let me show you the stars around these points. So here, tonight you'll be able to observe this. You see this pattern over here. This will form like an A shape or a V shape in the night sky. And then if you slowly zoom out, as in you look at it with your eye, you'll basically see something like this. And then when you look at this pattern, it looks like the face of an animal. Which animal? I don't know. Look at the stars around it. You've got two more stars over here. So if this was the face, and then you would have an antler kind of a shape over here. You would have an antler of a shape. So it has got kind of a antlers here. So you could imagine this to be a deer. But then what ancient Greeks did is identified these patterns, and their mythologies were based on this. So they have a bull with a giant horn that was basically a shape taken by Zeus the god for whatever his conquest was. And this bull was known as Taurus. So the Greeks named this as Taurus the bull. And even the Indians saw the same shape. You see a bull over here. Of course, the entire body of the bull is not visible like the animal I showed you earlier. You've just got the face of the bull, and a torso is also visible here. Similarly, if I move forward here at this point, if you see the stars over here, of course, with so many stars visible, this will be difficult to identify. But if we live in city skies, then not all of these stars will be visible. So some of these stars will disappear. And then if you just look at the bright stars, you can see two bright stars over here. And below this bright star, you've got a few stars forming a stick figure, a foot, a hand, a torso. And below this star, you've got the torso, the foot, and the hand. Let me make it visible for you like this. And then they identify these as two brothers or two figures. And this is what we today known as the Gemini Constellation. Similarly, as you move forward, you can see that you'll see another structure like this. You've got a few stars forming a face looking forward and then a torso. And given its majestic nature in the night sky, this was identified as Leo, or the lion. So you've got constellations like this throughout the entire sky. And if you identify these along the path of the moon and the sun, you would identify about 12 of these figures. And this is what we today know as Rashi or zodiac signs. And if you plot the position of the sun and the moon, they will always be across these constellations. So as you see, the moon will always go from, right now it's in Mithuna Rashi or Gemini to Cancer and so on and so forth. We all know these. We all know these constellations and things. But then how do we identify days with respect to this? So what ancient astronomers did is along this path of the moon, they identified bright stars, right? So today, if you were to look at the moon would be right next to this bright star over here. Right, this bright star over here, you would see the moon. Because the sun is right there, you might not be able to identify this. But in the coming days, let's set a date for the future. Let's say 5th of February. Yes, 5th of February, you'll notice that the moon is near, not many bright stars are in this region. Not many bright stars are in this region. But then you can, again, look above this region and you'll see a few bright stars over here. So what ancient astronomers did is identified some of these bright stars near which the moon would appear, and they could identify 27 bright stars, and today we call them the Nakshatras. Let me tell you one small point over here. When we say Nakshatras, of course, the Sanskrit or a regional language will tell us that a Nakshatra is a star. No. When they identified the Nakshatras, they were basically either a star or a group of stars. For example, when you identify the moon, on about 9th February this year, you'll see that the moon is very close to this small group of stars over here. This group of 7 stars that we see is the Kritika Nakshatra. I said 7 stars. It's not one star. It's a group of stars. That's Kritika Nakshatra. But on 10th, you would see that the moon is next to this bright star, and this is one star, and we call it the Rohini Nakshatra. And then on 11th February, if you see the moon, it will be very close to this star, or again this star over here, this group of stars over here. And ancient Indians saw this hunter that I showed you earlier as a deer. You can see here clearly that it appears like a deer, right? And later they identify this as a hunter and its face. So Murga was what we identified, and the hunter was later identified, and its face, Shira. So Muragashira Nakshatra. This is a group of 3 or 4 stars. Similarly, every single day they identified the position of the moon with respect to these stars. So you've got Ashwini, Bharani, Kritika, Rohini, and so on and so forth. On 13th February, you'll see the star next to these 2 bright stars over here, of which this bright star is the Punarvasu Nakshatra. And similarly, as you move forward on 14th, 15th, and 16th February, you'll identify the moon next to this very bright star. I'm skipping a few days here because today, given the light pollution and the Earth's atmosphere that we have reached at this point, some of the faint stars are not visible. So Aslesha, Pushya, these are all stars or nakshatras or figures that we can't see. But what you can do is identify the moon next to this bright star here on the 16th of February. This is the Makha Nakshatra. And the next day, the moon will be closer to this star over here, which is Purva Falguni. And the next day, the moon will be identified near this star, which is Uttara Falguni, right? And slowly further, you will find out that the moon will be identified next to this group here, which is the Pushya Nakshatra. Oh, sorry, Hasta Nakshatra, which is a group of 4 stars. In fact, this constellation itself is Hasta. And then on the 20th of February, you'll see moon close to this star over here. But before that, there's another star over here on this line, which is perpendicular that path. So we identify this star as that day. This is the Swathi Nakshatra. And then again, if you move forward, you've got Chitta Nakshatra, and then you've got the Jyeshta, Mula, and so on and so forth. So the moon will move across the sky with respect to these stars. And these 27 stars are used to identify the days. Similarly, if I were to identify the sun's position, like I told, you identify the stars, these patterns, these stars, and the sun will also appear near these stars. So what ancient astronomers did is they identified these patterns in the night sky, and then they said that let's call them Rashi. So I showed you the bull's face earlier, right? I showed you the bull's face earlier, and then I showed you the 2 stick figures over here, and then further down I showed you the lion over here. So these are all figures that they identified, and today we call them Rashi. Now, because we all are learning all these, we can learn all these systems today, and with the help of these apps, we can identify these patterns. I would like to point out one very important fact, that the ancient astronomers identified these figures as regions in the sky with use of degrees. So when we say Vrishchika Rashi or the Taurus constellation, it was not this particular position in the sky. It was somewhere between this region to this region in the sky. And all the stars between this angle would be belonging to this Rashi. This is why today, if you identify the Mrigashira Nakshatra, which is in this group over here, it falls under the Orion constellation. But we say it's in the Vrishchika Rashi, which is the Taurus constellation. That is why I will refrain from using constellation. And when I say Rashi, you need to identify it as some amount of space, some amount of region here. Similarly, when I showed you the Swathi Nakshatra here, Swathi Nakshatra is so far away from the figures that are formed here, right? So when I show you, you can see in this region, you can identify a small figure, and they identified this as a woman, Virgo, the Virgin, as the Greeks called her. But the Swathi Nakshatra is so far away from this group over here. But to ancient Indian astronomers, what that mattered is Swathi Nakshatra belong to this region in the sky. So it is still in the Kanya Rashi. So let me just switch to the presentation. So what we have studied so far, and of course in school they teach us about planets and stars, but not the patterns. You can observe the night sky with respect to observe the position of the sun and the moon with respect to the night sky. And I showed you that you can plot the position of the moon. Now, before I explain any further, we will use the term called the celestial sphere, or khagol we call it, which is basically imagined as the earth being in the center of a sphere, and inside the surface of the sphere we have got the various stars. So this is astronomy. When you say astrophysics, we talk about the stars' distance, their temperature, and so on and so forth. But when I say celestial sphere, we imagine that all the stars are at an equal distance from the earth and are inside the sphere. That is all that matters to us when we talk about calendars. So like I told you, with respect to the earth, when you look at the sun, you look at the star at midnight. Let's say it's in this region. Today we call it as the Aquarius constellation or Kumbha Rashi. Then I know that the sun right now is in Simha Rashi. And slowly as the months pass, the sun will appear to move because the earth is going around the sun. The sun is going to be there itself, but the earth is going around the sun. So when the earth comes here, that straight line will be forming over here, and we say the sun is in Vrishchika Rashi. So when I talk about the nakshatra, we can talk about it with respect to the sun and the moon. And I told you, and we've learned in school, that the earth moves around the sun, and one complete rotation we all know is 360 degrees. So one revolution around the sun will take 360 degrees, and we could identify 12 of these patterns. Of course, if you go out tonight and observe these patterns, some of them will be very long, like Virgo is a very large constellation. Leo or Simha Rashi is a very large constellation. You say Capricorn, it's a very small constellation. So if you identify them as the modern constellations, they are not going to be exactly this much of a width. But what our ancients did is they identified these patterns and labeled them for 30 degrees space. So when I say one pattern, one Rashi, it is basically 30 degrees along the path of the sun or the moon. When you observe the moon, again, the 360 degrees that the moon goes around this earth is identified as for 27 days, or identified by the 27 bright stars or clusters that I showed you. So the one bright star spans about 13 degrees. So when I say one bright star or a nakshatra, I'm not talking about that nakshatra. That is just an identifier. When I say the moon is in this nakshatra or today is this nakshatra, we are talking that the moon is in the space of 13 degrees. So total number of nakshatras today we've identified are 27. Of course, there are 4,000, 5,000 stars that you can see, but these bright stars or patterns that we've identified today, all of us know this, are the 27 nakshatras. Of course, we know the names. I'll not say out all the name, but we know the pattern: Ashwini, Bharani, Kritika. And because the moon is moving in the night sky with respect to the background stars, they will always follow the same order. So this makes up for a great calendar. So every day the moon will appear near one nakshatra. So it's going to be Ashwini, Bharani, Kritika, Rohini, Mragashira, Ardra, and so on and so forth. Today, if I want to identify the moon right now, let me identify the moon. Let me show it to you. Yes. So you can see that the moon is close to this bright star I told you here. So today's day would be Uttarashada, because this star here, this bright star here is Uttarashada. Of course, it takes a little bit of practice to know these stars by their names and patterns. So the moon here would be in Sagittarius constellation today, or Rashi. And in Sagittarius, we've got this bright star identified as Purvashada, and this is the Uttarashada. So this is how we identify the position of the moon. And when I talk about Rashi, I told you the 12 patterns. They've been identified with figures, and today we know them as Mesha Rashi, Rishabha Rashi, Mithuna Rashi, Karkataka Rashi, Simha Rashi, and so on and so forth. Now, the beauty of this is when you look at the sun with respect to these Rashis, then you'll identify that the sun will spend some amount of time in every Rashi. So let me just enable the images so that it's easier for you to identify. And today, right now, the sun is in this Capricorn or Makara Rashi. And it's 30th January, 31, 1, 2, 3, 4, 5, 6, 7. The sun will exit this Rashi on about 15th of this month or so. And then it will enter this Kumbha Rashi or Aquarius constellation. And again, the sun will slowly make its way through this Rashi and then enter into another Rashi, which we identify as the Meena Rashi. Two fishes are over here, right? So every single day, the sun moves slowly with respect to the background stars, and the sun will move through these patterns or Rashis and enter one and then exit the same after 30 days. And similarly, you can identify that there are 12 of these shapes that the sun enters and exits. So this is why we've got the Mesha, Rishabha, Mithuna, Karkataka, the Simha, and so on and so forth. So that is why we've got 12 months in a year. So 12 months in a year comes from the 12 Rashis that the sun appears to be in. Of course, the sun does not appear to be in a Rashi. I told you we can't identify the stars behind the sun, but there are methods to find these out. And then this is what forms the base of the 12 months. And in India also, we identify this as the Sauramana calendar. And in this calendar, we identify the month with the name of the Rashi itself. So we say Mesha Masa, Rishabha Masa, Mithuna Masa, Kataka Masa, Simha Masa, and so on and so forth. So this is the Sauramana system. There are many calendars across the world that follow the solar pattern. The Gregorian calendar, the Julian calendar, they all followed the sun's position. And that is why we've got the months, the 12 months. And like I told you, if you sit and identify every single month, there's going to be a span of 30 to 31 days that the sun will spend across these constellations. That is why we've got 30 days in a month. So when you go by the moon's system, again, we've got the moon will be in these 12 systems itself. So if I were to identify the moon's position with respect to these months, I would still have the Chandramana Masa. And they've got a different name. They don't have the name with respect to the constellation. They've got the name as the Chaitra Masa, the Vaishakha Masa, the Jyeshta Masa. Why does the name differ? Because the people who identify the moon as the source of the calendar will identify that the moon will appear with respect to the background stars. And I told you there are 27 days when the moon completes one cycle. But if you observe the sun's position and the moon's position, the moon will appear as a full moon once every 30 days. So where has the moon gone? Let me identify. Yes, the moon is over here. And I told you the 1st of February is going to be a new moon day. So let me just zoom into the moon and show you the moon. 1st of February is going to be the new moon day. And then slowly I told you the moon will appear as a full moon. And on the full moon night, if you observe the moon, then the moon will be right next to one of the nakshatras. And we identify this nakshatra as that month's name. So you can see that the moon is next to this month, it's next to the here, Regulus, or this is Makha Nakshatra. So this month, the full moon is next to Makha Nakshatra, and that is what gives it the Magha Masa. So the bright stars among the 27 nakshatras that we identify, when the full moon is spotted next to one of these, then we identify that name of the star as the month. So here I've got where's Makha? Yeah, Regulus. I showed you Regulus is over here. So Regulus or Makha Nakshatra is what gives it the name Magha Masa. And then the next full moon. So let me just zoom into the moon again and show it to you. The moon is going to go through phases. So with every passing day, the moon will go through phases. And from new moon to full moon, we will wait. And when the moon is full again, we will slowly go back and identify the star that is next to the moon. And right here, we've got this bright star over here. And this is the Falguni Nakshatra. So we've got the Falguna Masa. That's Denebola star. So when the moon is next to a bright star or a pattern on the full moon day, we identify that star as the name of the month. So Chitta Nakshatra or Spaika gives us the Chaitra Masa. Vishakha Nakshatra gives us the Vaishakha Masa. Jyeshta Nakshatra gives us the Jyeshta Masa. Uttara Ashada Nakshatra will give you the Ashada Masa. Shravana Nakshatra will give you Shravana Masa, and so on and so forth. It's Shravana Nakshatra, sorry. Sometimes you've got the Ashwini Nakshatra and the month name is derivative. So Ashwayuja, Kritika Nakshatra, Kartika Masa. So these 12 months in the Chandramana calendar comes from these bright stars. And this is how you identify the months. Now, this is used, this is identified using the full moon. And I told you the distance between the full moon and the new moon is 30 days, roughly. So that is why we've got 12 months in the Chandramana calendar as well. Right? So the full moon and the new moon are identifiers. And based upon the region in India, we've got the Chandramana followers who identify the new moon as the first day of the month, and some of them identify as the full moon as the first day of the month. That depends from time to time, but the names are identified using the same pattern. So once I told you the stars that the moon follows is a fixed order, and the moons will also be the same. Now, there's one important concept that you'll come across in a calendar, that is the Adhika Masa. Where does the Adhika Masa come from? This comes from the synodic and the sidereal period of the moon. Now, when I say full moon to full moon or new moon to new moon, we are taught in school that the full moon and the new moon are because of the patterns of the sun and the moon. So you see that the moon will go around the earth like this. And as the moon does that, the earth will also go forward. So when the moon is here and this earth is here, we see this is the new moon, right? And as the earth moves forward, the moon will appear every single night to be at this position, right? And I told you with respect to the background stars, the moon will complete one rotation on 27 days, right? So when the earth will have reached at this point over here, the moon will have come back to the same position with respect to the background stars. That's why the horizontal arrow. Let's say some star is over here near the red pointer over here that I've kept over here. So at this point and at this point, both direction, you've got the same background star. So the moon will appear to complete one rotation with respect to the background stars on 27.3 days. But 1 month with respect to full moon and new moon occurs when the moon will again come in between the earth and the sun. So when the earth is here, the moon has not yet come in between the earth and the sun over here. So as the earth moves a little forward, the moon will come in between these two and we have a new moon. So this period takes 29 days. So this is known as the sidereal and the synodic period. And if you do this every month, if I consider 27 nakshatra system as my calendar, then every single month we will have a shortage of 2 days, almost a little less than 2 days between these two calendars. So the new moon to new moon calendar will have about 29.5 or 30 days. And the nakshatra system or the tithi system will give me the basically 27 days. So if you add this up, every month you'll lose a little less than about 1.8 days. So when you keep forwarding this up, let's calculate this later. Let's carry on. Over a span of 3 years, this 1.8 days will sum to almost 1 month. So this is why to offset, because if you keep doing this, our entire calendar system breaks down. So to keep this back into sync, to bring the entire system back into sync, the Chandramana and the Sauramana system will go forward a little. There's a small difference, and it'll come back to the same position when we add 1 month every 3 years. And this is known as the Adhika Masa. And again, based on the various faiths, there are importance to this day or this month. But in the calendar system, in the astronomy system, this is what happens. So this is why we have Adhika Masa. And in the solar calendar system, the Gregorian or the solar calendar system, we are not considering the moon at all. That is why we have just got 30 days. And then there's a small offset because it's not exactly 30 days and this pattern happens. This is why we've got the 31 days month. In fact, before Julius Caesar, we had 30 and 31 days in every month like normal. And February also had 31 days, right? But then because Julius Caesar was the leader of Rome that time, and to give importance to his month, the month where he was born, which was basically July, they added 31 days to July. By removing February is one day, and that's why we have got this. And then again, if you calculate this Earth moves movement with respect to the Sun, there's a small difference. The Earth takes about 365.25 days to complete one rotation. So if you go by the normal calendar system, this 0.25, if you add it 4 times, it becomes 1. That is why once every 4 years, we've got a leap year. That is, one extra day is added to February. And then over a span of thousands of years, this difference will also have an extra second, and which is what we popularly know as leap second today. And quickly before I wind up, the position of the Earth with respect to the Sun, because the Earth is tilted at a small angle of 23.5 degrees, we've got the seasons, and these are known as ritus. In fact, we are taught in India, given the position of the country with respect to the Earth, three popular seasons, three main seasons are followed. That is the summer, winter, and the rainy season. But across the entire Earth, we follow four season system, which is basically spring, summer, autumn, and winter. Okay, and that is given by the four position of the Earth given here. And in India, we've got basically six of these systems, right? We've got the Vasanta or the spring season, and from the spring to summer, that region, we've got nothing else. So from Vasanta, we've directly got the Grishma Ritu or the summer season. And between that summer season and the Sharad Ritu, we get the rainfall. I mean, it used to before, not now. So we've got the monsoon season or the Varsha Ritu. Then the monsoon will slowly stop and the cold begins, which is when the Sharad Ritu happens, when the trees leaves will start falling, and then winter comes in through the Hemant and the Shishira Ritu. So the season is also identified, and this is exactly why we see the position of the sun not being in the east or the west exactly every day. And this is what leads to the position of the sun. Okay, so you can see that as the earth rotates, the northern pole over here, the North Pole region, or some countries in that region as well, will not receive sunlight for the entire duration of the day. This is during December 21st. And similarly, yeah, this is what happens. The southern pole receives the sunlight for the entire day. And as we move forward through the months, this orientation will change. And this is why the sun's position in the sky will also change. So you can see in this beautiful image over here, in the December, the sun will appear the maximum towards the south. And as January happens, the sun will start moving towards the north. So you can see from the south, it will move towards the north. January, it has moved towards the north. February, then in March, it has moved towards the north. April, May, and June. On June 21st, which is known as the June solstice, the sun has reached the maximum position in the north. And then from then on, June, July, August, the sun will slowly move towards the south, and it will reach the maximum southern point at December. So this is how you can identify the months or the seasons as well. And this is what we call as the ayanas, the Uttarayana and the Dakshinayana, right? So when the sun moves from north to south, we call it Dakshinayana, which is from June 21st to December 21st. And from December to June, we've got the Uttarayana. That is what the whole Makara Sankranti and all that is celebrated regarding. One small observations that you can do about planets is, of course, we can find planets tonight using apps and so on and so forth. You will notice the planets will also move in what is known as the retrograde motion. Okay, and the planet will appear to move forward for a while, and then again it will appear to move backward for a short duration in a year, and then again it will appear to move forward. So if you take a photo of the planet every day and make a composite of it, this is what you find out. This happens only in the outer planets because the Earth is an orbit smaller than the outer planet. So as it overtakes the planet around the sun, you will see this kind of a pattern. But that has nothing to do with the calendar. This is just small observations that you can make. So for those of you who are interested in identifying these patterns, because they've introduced me as a coordinator of PAC. PAC is a small group we have online on Facebook. You can find it and just give PAAC, and you can learn astronomy through this ways. So I hope this session has been useful and has given a small insight about the calendars and how they are formed. And all of us can go out and observe the position of the moon every single night and identify these months. So hereafter, these months The Chaitra Masa, the Vaishakha Masa, the January, the February, and all are not simply some things that are given to us in the form of calendars in school. We know how to find this out. And to wind this session up finally, I haven't explained why we've got 7 days in a week. That is only because the full moon to new moon cycle, about 14, 14.5, 14.8 days, the 14 number is divisible by 7. And again, the month can be divided into 4 of the 7 days group. And that is why we've got the 7 days week. And that has no astronomical significance. So thank you. I hope this session was useful.
Thank you so much, Mr. Atul. It was really innovative and interesting. As they say, the sky has no limits. So we, learned so many new things. We knew all those terms, but we never knew why and how. And I think that was the explanation you gave us today. So that was really informative. And one thing more, can you put the links and the app in the chat box? So we can share it with the users, and we can put it all the apps and links in the description box of a YouTube channel.
Sure.
So anybody has any doubt, and the crossword you showed us, that also link if you put it, so anyone interested can solve it. So you can put it in the chat box of a Zoom, then we can post it in the description box. Yeah. And other thing, I'd like to thank Dr. Muralidhar Rao for introducing us to you. I think, and because of this, we got so much, so much of information on astronomy. So we are ending this session. I hope all of them loved it. Before ending, I'd like to thank the audience, who are the most important part of any program. We thank you for being part of the BSKBA Youthwing family and encouraging us to look forward to the next session every time. We thank the President and the Managing Committee of the BSKBA Association for giving us this opportunity, as well as for the support and encouragement for helping us to provide this platform for the vast talent pool of association. We also thank Guru Prasad Bhat, Tanvi Rao, Janvi Poti, Bhargavi Poti, and Supriya Udupa for the coordination. Please subscribe to our channel and follow us on Instagram by the name Youthwing BSKBA. Thank you all for joining. Namaskara.